In this video, we are going to describe the break distance problem. And now, we are going to speak about the two break distance problem. And to do so, we pass from the previously linear chromosomes, as in mammals, to circular chromosomes. Black direct edges represent synteny blocks, and we are going to define them in the next slide. While red undirected edges represent adjacent synteny blocks in the same chromosome. What is a synteny block? A synteny block is a continuous cDNA sequence that is not randomly transmitted, like a haplotype, for example, is an example of a synteny block. During recombinations, the breakage points are not random. Now, we return to the previous slide now that we know what is a synteny block. And we notice that A is positive and is clockwise, while B minus B is negative and the arrow is anti-clockwise. Again, we have lines connecting adjacent synteny blocks. And now we have equivalent representation of a circular gene. I don't like the representation on the left because the order is A, B, D, C, it is weird. While I like the one on the right because it is ordered in alphabetical order. A, B, B, D, D, C, and CA. But the circular genome is represented as A, B, C, D, and in this way I can compare the synteny blocks of these genomes with the one of a different one. Now, we are going to apply a reversal. We remember what is a reversal from the previous slide. Chapter, my apology. I apply reversal to C to minus C plus D, becoming minus D plus C, and I'm going to see how to do it now. A is connected to B, and it is not clockwise, is anti-clockwise. B is connected to D, but it is anti-clockwise, so is minus D. D is connected to C in a clockwise way, and C is connected to A, clockwise to clockwise. What did I do? I break these arcs. A reversal deletes two red edges and replaces them by two other red edges on the same four nodes. I deleted these two red edges and replaced one the red edges with this one. Now we are going to speak about fusion and fission. A fission is a division of a graph in two. I divide the cycle ABCD in two independent cycles, AB, the first one, and CD, the second one. I wish you to notice this as the parentheses. And the fusion, when I'm going to replace two arcs on the two different graphs on two arcs on the same graph to obtain a single cycle. What is a two break? A two break is a rearrangement that replaces two red edges with two new red edges on the same four nodes. And now we are going to speak about translocation on linear chromosomes. I'm going first of all to circularize the linear chromosome. I have minus A here, so I'm going to write A anti-clockwise. After plus B, so B clockwise, C positive clockwise, minus D anti-clockwise, and I'm going to glue minus D with A, and this is the first chromosome. The second chromosome is E clockwise, F clockwise, G anti-clockwise, minus G, and H clockwise, and I'm going to glue them between H and D. Now I'm going to apply a two break to join these two chromosomes. Before I had two circular chromosomes, now I have one circular chromosome. But if I'm going to break the connection between D and A, where I have the glue originally, I'm going to linearize the two circular chromosomes. Now, okay, you see.